everyone, welcome back to this channel. Today in this channel we are going to discuss about chapter 2 class 10th polynomials. So let's get started up without wasting much time. First thing first, what are the topics that we are going to cover up in this session is we are going to first introduce what do we understand by the polynomials. Then we'll head up to geometrical meaning of zeros of a polynomial. And finally, we are going to discuss about relationship between zeros and coefficient of a polynomial. So let's get started up first with the concept. Now, what do we understand by the polynomial? So like usual, I just tried what do we understand by polynomials. Okay, so we must have a basic knowledge from class 8th, 9th, even at 7th, what do we understand about by your algebraic expression? Algebraic expressions are generally consist of your variables and some constant terms along with some coefficient of the variable such that the degree of that variable can be any rational number. But in terms of your polynomial, it is again an algebraic expression, but the degree of this polynomial will always be a whole number. So how you are going to define that polynomial is an algebraic expression with degree of variable or power of the variable being a whole number will be a whole number. I hope this concept is clear. So whenever I'm writing a polynomial, it is written as p of x, polynomial with a degree, with the variable as x. So it will be written as, let's say I'm taking x raised to 4 plus 7 over 2 x square plus 3 over 5. So this will be a polynomial. Please note the coefficient over here. These, this and this. These are the coefficients. This is called as your constant term with no variable. And this is called as your coefficient. And x is nothing but your variable. If the coefficient is not written, it will be considered as your 1. This is again your coefficient. Okay, I hope this concept is clear. An algebraic expression with the degree being always a whole number. Now, if I tell you that let's say the polynomial px is 1 over root x minus 1. Or it is something like 1 over x square minus 2x plus 1. Now just let me know, are these the polynomial? The answer will be no. Why? Because first in this case, the polynomial has the degree being rational, that is 1 over 2. So this will definitely will not be a polynomial. It will not satisfy this condition. Also, this polynomial is written in the denominator. It's always an important point that the polynomial, all the terms should be in numerator. There is nothing, the variables should be in numerator instead of denominator. So this is not a polynomial. So the generalized form of a polynomial is nothing but equals to summation, just representing with the sigma notation, or else let's first write it as a0 being the constant term, a1x plus a2x square and plus so on till an x raised to n, where an, like your ai, where I is running from 0 to n, is just belonging to your real numbers, and the degree is nothing but belonging to your n belongs to your whole numbers. This can be written with the sigma notation as summation of your ai xi, where I is running from 1 to, or not 1, it's 0 to your what? N in this case. I hope this concept of polynomial is clear. Now the next topic is your degree, because we have used a term as degree. Degree is nothing but the highest power of a polynomial. For example, if I am talking about px is nothing but equals to x raised to 8 plus 7 x raised to 5 plus 1. Now in this polynomial, the highest power of a variable, highest exponent of a variable is nothing but your 8. So we call it that this is a polynomial of degree 8. Polynomial of degree 8. Similarly, if I am writing x raised to 24 plus x raised to 26 plus x raised to 28 plus 1 being one of the polynomial, then what will be the degree of this polynomial? Just have a look which is the highest power. Highest power in this case is 28. So this is a polynomial with degree 28. I hope these are all crystal clear. Now we'll define up the types of polynomial. I'm just rubbing this off. You can take a screenshot by pausing the video. Alright, now what are different types of polynomials? This we have already covered in class 7th, 8th, 9th as well in terms of your algebraic expression. We'll cover in polynomials as well. Let's get started up. So first thing first, what do we understand by the types of polynomial? So first category to have this is nothing but based on number of terms. Based on number of, we are writing number of terms. So based on number of terms, I can classify a polynomial first being a monomial, second being a binomial, and third being a binomial, and third be trinomial, and all the higher powers will be classified as your polynomials itself. So what do we understand by the monomial? Monomials are nothing but a polynomial with only one term. The word mono over here represent one term. For example, if I have a polynomial with one term, let's say a constant term, or a polynomial with only x square, or a polynomial with only 7x squared, just one term. So these types of polynomials are nothing but called as monomials. Similarly, what do we understand by the binomial? Polynomial with two terms. For example, I'm writing 2x squared plus 7, or I can write a polynomial as 7x cube or 7x raised to 4 plus 5x. These polynomials contains only two terms, any terms of any order, but these are just two terms are called as binomial. Lastly, trinomials. Now I think this will be clear. This is nothing but a polynomial with three terms. For example, I'm writing x squared plus 2x plus 1, or I'm writing x raised to 5 plus 4x raised to 3 plus x. This contains only three terms. Do note the terms are being separated with an operation of either an addition or a subtraction. Either it can be addition, it can be subtraction. It cannot be separated with multiplication and division. Then this will not be considered as your binomial or trinomial. Okay, this must always be separated by either an addition or a subtraction operation. Alright, then this was on the basis of number of terms. Second classification is on the basis of degree, based on degree of the polynomial. So based on the degree of the polynomial, we have again a different classification, which is nothing but your linear polynomial. What do we understand by the linear polynomial? As degree. Linear means just 1. If the polynomial has a degree 1, highest power is your 1, is nothing but called as linear polynomial. For example, I am writing 2x plus 5. The highest power in this polynomial is nothing but your 1. Thereby, this is called as linear polynomial. The second type is nothing but called as quadratic polynomial. What is quadratic polynomial? A polynomial with the degree highest power being 2. So I can write it as 2x squared plus 5. Now I am not classifying with the number of terms, just highest power to be 2. Or I can write it as 2x squared, not 2x cube, 2x squared plus 5x plus 7. So the polynomial has the highest power as your 2. Then you can have the quadratic. After then you can have a cubic as well. So what is a cubic polynomial? A polynomial with the highest power as 3. So I can write it as an example, 3x cube plus 5x square plus 7x plus 8. So this is just a polynomial with the highest power as your 3. I hope this is clear. After then, the fourth power, the fourth degree is nothing but called as quartic and so on. Till now, you just have these three one: linear, quadratic and cubic. Any doubt so far? Alright. Now we are going to discuss about just an important concept, that is geometrical representation of finding the zeros. Okay. Then we'll start with some questions. Now, what do we understand by the zeros? We'll discuss in detail, but over here we are just going to discuss about the geometrical representation. So basically what happens is, suppose the zeros, first I'll explain what do we understand by the zeros of the polynomial. So zeros of the polynomials are nothing but the value of your x at which the polynomial turns out to be 0. I'll explain once again. For example, I have a polynomial as 2x minus 1. Now, if I plug in my x is nothing but equals to 1 over 2, I'm gonna get twice of 1 over 2 minus 1, which is nothing but 1 minus 1, which is 0. So what do I say? That the polynomial value at 1 over 2 is nothing but turns out to be 0. Thereby, this 1 by 2 is called as 0 of the polynomial. 0, or you can call it as roots of the polynomial. Isn't it? So this is nothing but the definition of your zeros. Now, what is the geometrical representation or interpretation of this concept? So basically, in your x-axis, if any graph, we know that a cubic polynomial has a straight line. Not the cubic, the linear polynomial has a straight line. The quadratic polynomial is basically having a parabola. Being a quadratic, this will always be a parabola. Parabola is just a U shape. Okay, it can be a U shape to this side, it can be a U shape to upside, it can be a U shape to this side, or it can be a U shape downward. If you take the collective point, you are always going to get a parabola. Linear is always a straight line, as the word itself says, linear, a straight line. Cubic polynomial has a graph of like this. Okay, like this, or you can say like this. It can cut at any point. This is actually nothing but called as x cube. You can use your Google, just type the function x cube graph, you're going to get your x cube. Or else you can take different point of x, for example 0, 1, 2, 3, so on. What will be the value of x cube, and then you can plot the graph. So definitely you are going to get these types of graphs. But that is not the area of concern. The area of concern is how you are going to get what is the geometrical interpretation of your zeros. Now basically, this is very important. How many times a graph cuts the x-axis? I'll repeat the point. How many times the graph cuts the x-axis? I'm not talking about the y, just the x-axis will be called as the zeros. Okay. Algebraically, you can define by just placing that point into the polynomial, whether you are receiving a 0 or not, will be 0 or not. But graphically, how you're going to examine whether it is a 0 or not, how many zeros do I have? So if it is cutting the x-axis and how many times it is cutting the x-axis will give you the number of zeros or whether the zeros exist or not in a polynomial. I hope this concept is quite clear. Now, let's get started off with first question. This is for your exercise. Exercise 2.1. The first question on your screen is right there. I want you to please read the question carefully. See, the graph of y is equals to px are given in figure 2.10. For some polynomials px, find the number of zeros px in each case. Now, the answer should come from your side, although I am not listening, but you can comment down. Right over here, for the first part, how you're going to find the zeros in your polynomial. So, my basic strategy will be nothing but my x-axis is the key point. Okay, x-axis, just check, is there any line which is cutting the x-axis? No. At any point, No, it is just cutting your y-axis, but I just have to take care from my x-axis. So what I'm gonna say that there is no solution or no zeros in this case. Zero, root, solution, all are the same term. No zeros in this case. Okay. Now coming back to the second part, I'll notice that it is cutting the y-axis over here, but this is not the point of consideration because I have to find the number of zeros. Only the x-axis. X-axis it is cutting over here. Only once. So how many zeros exist? Only one zero exists in this case. Coming to the third part, check at x-axis where it is cutting 1, 2 and 3 times. So the number of zeros is nothing but your 3 zeros. Okay, lastly over here of fourth part, this and this 2 times, so the number of zeros is nothing but your 2. Similarly 1, 2, 3 and 4, so number of zeros is 4. Lastly, let's have a look. 1, it is not cutting but it is touching it. Touching also means that it is, like for example, suppose this is a graph which is touching the x-axis. That means the root over here will be the double root. We'll discuss about the discriminant in the next chapter, but this means that there is double root. Touch or cut means that this will be the root of that particular polynomial. Over here as well, this is actually touching that, not intersecting. So how many roots do I have in this case? The number of roots are nothing but your 3 zeros. How many zeros do I have? Number of zeros are 3 zeros. I hope these are crystal clear. This is zeros. Okay, this was the question number 1. I'll start with the next concept now. I hope this portion is crystal clear. Okay, moving on. What is the next question, next concept that we are going to discuss? So the next concept is zeros, like the zeros of the polynomial. What is the relation between the coefficient as well? Okay, so first thing first, now you will be given a quadratic equation. To be very openly explaining, see, I'll just give you one quadratic equation starting with simple one, x square minus 2x plus 1. Now you will say it's just a x minus 1 to the whole square, isn't it? With our basic identities. Now you have factorized this as x minus 1 and x minus 1, isn't it? Now if you carefully notice that if I compare these two, what I'm gonna get? I'm gonna get x square, just multiply once again, x square. So over here if I write, what are the roots? Roots are nothing but your 1 and 1. So if I multiply this up, I'm gonna get x square minus x plus 1, which I can write it as x square minus of 1 plus 1 of x plus of your 1. Compare it with the standard equation as your x square minus 2x plus 1. If you compare, what I'm gonna get, this is nothing but, this particular term is nothing but your sum of root, isn't it? And this particular term is nothing but over here, which is the product of root. Or to more generalize this concept, let's start with a basic quadratic equation, ax square plus bx plus c. This is your polynomial. Let's say I have a root being alpha and beta. So I can factorize this up as your x minus alpha and x minus beta, isn't it? Now if I multiply this quadratic equation, these two factors, I'm gonna get minus of alpha x minus of beta x plus of alpha beta. Okay, now if I generalize this, take out common, so I'm gonna get x square minus of x alpha plus beta and plus of alpha beta. Okay, now this is nothing but equals to a x square plus bx plus c. If I take a common from this, what I'm gonna get, x square plus b over a of x plus c, which is nothing but equals to a x square minus alpha plus beta of x plus alpha beta. Okay, Now just have a look. Compare both the side. What you are going to get? This is nothing but equals to sum of root. Sum of root, which is nothing but equals to minus alpha plus beta. And on the left hand side, you are going to get your b over a. This is the one important formula that we are going to get. Sum of root from the basic equation, how you can find the sum of root? It's nothing but equals to b over a. B is just the coefficient of the variable x. A is the coefficient of x square. Okay. Now comparing with the second part, which is nothing but the product of root. So over here, if I compare the product of root, this and this is also a, no? If I take common a, so what I'm gonna get, the product of root is nothing but equals to alpha beta. Now comparing both sides, I'm gonna get my alpha beta is nothing but equals to c over a. So this is c over a. Okay, so this is my another formula. What is the formula for sum of root? Sum of root is nothing but equals to minus of b over a. I'm just having this being my sum of root. Negative I'm shifting to this side, so this is minus b over a, and product of root alpha beta is nothing but equals to c over a, isn't it? Now from this itself, if I say you please make a quadratic equation, if you have sum and product being given, if this and this is given, compare it with this again. What does a quadratic equation actually have? A quadratic equation actually have a sum of root. First it has an x square, after then it has a sum of root. That means the sum of root is nothing but equals to negative of sum of root, that is x, plus product of root, or you can say positive. Why I'm placing negative, I'll just explain. This is sum of root plus product of root. What is sum of root in this case? Sum of root is nothing but equals to minus b over a of x plus b over a, c over a. Thereby we place a negative sign over here so that this turns out to be this. This is your negative sum of root plus product of root. So if I have a negative over here, so this will originally turns out to be positive b over a of x plus c over a. Are you getting my point? This is what my original function is. So this is nothing but equals to negative sum of root, and this is nothing but equals to the product of root. So how to make a quadratic equation? Just x square minus sum of roots times x plus product of root is equals to 0. This is your quadratic equation. And what are the relation between quadratic equation and the coefficient? Sum of root is your minus b over a, product of root is nothing but equals to c. Very important concept. I hope it's clear. Any doubt so far? Otherwise, we'll move on to the next example. Next example we have, find the zeros of the polynomials. X square plus 7x plus this. Now for zeros, you should know how to factorize the polynomial. So to factorize, many of the students don't know how to factorize as well. So keeping that thing in my mind, I'll just explain how to factorize. If you already know, you can just take a minute and then we'll start with this question. So how to factorize? Just have a look at the coefficient. I'll change the color to explain. This coefficient and this constant term. Multiply this 1 by 10. You are going to get 10. Okay. Now factor this. That means split this 10 in such a way, the addition and subtraction, either addition or subtraction of these two factors must give you a positive of 7. So I know if I split this 10, it's nothing but 5 times 2. And I know 5 plus 2 will give you a positive of 7. Thereby, what will be my factors? I'll split this 7 now with 5x plus 2x plus 10 is equals to 0. Thereby, you are going to take x common in both the terms. You are going to get x plus 5 left. From the second, third and the fourth term, take 2 common because nothing can be taken out common from here. So this is x plus 5, which is equals to 0. Now if your factors are done in a proper way and if they are correct, you will notice that this bracket are always the same. So you can take this bracket common once again. X plus 5 is common. You are left with x plus 2, which is equals to 0. So thereby x plus 5 is nothing but equals to 0, and x plus 2 is nothing but equals to 0. So x will be nothing but your negative 2 and x will be nothing but your negative 5. These are the factors of this, or zeros of this polynomial. I hope it's clear. Now, the next part is they're asking additionally which color to use. Let's choose sky blue. Yes. And now you have to verify the zeros and coefficient. Verify the relationship between zeros and coefficient. So how you're going to write? So first you have to start with, in your boards as well, verification. Then you have to write, we know that sum of root, alpha and beta are the two roots, sum of root is minus b over a. Product of root alpha beta is nothing but equals to c over a. Compare, if you are getting confused, write over here what is a, what is b, what is c. Make sure there is a proper order from x square, then lower than that, then lower than that. That means x square, x, and then constant. So what do we get over here? Alpha plus beta is minus b over a. So start with your first part. This keep it as first, this keep it as second. This is how you have to proceed in your boards as well. Start with your left hand side. Left hand side is your alpha plus beta. Take this to be alpha, this to be beta. Alpha is nothing but your negative 5, negative 2, which is nothing but your negative 7. Start with your right hand side. Right hand side is nothing but negative of b over a, which is nothing but negative. What is b? 7 over 1, which is nothing but 7 over 1. Hence we can say that left hand side is equals to my right hand side, hence verified. Start from this was the first part, then we'll go with the second part. What is the second part? First, start with your left hand side, the product of root, which is nothing but equals to alpha beta. Alpha beta is nothing but equals to negative 5 times negative 2, which is nothing but equals to positive of 10. Then start with your right hand side, which is nothing but equals to c over a. Have a look. C over a. C over a, compare it from the original equation given. This is 10 over 1. Thereby your left hand side is equals to right hand side. Hence verified. And therefore you are going to get a full marks over here. Okay, first zeros, then verification. Simple. Coming back to the third example, find the zeros of the polynomial x square minus 3 and verify between the zeros and the coefficient. So again a simple thing. If you carefully note that the polynomial in this case is given as x square minus of 3, which is nothing but equals to 0. Now there are two ways to do this. If the simple way, I'll explain the method 1 because most of the students understand the method 1. Some of you like the method 2 as well. So I'll explain with method 1 and method 2. Method 1 is x square minus 3 is equals to 0. So I'll write x square is equals to 3. Then I'll write, if I remove my square from my left hand side, then it will turn out to be plus minus on the left hand side, on the right hand side. That means x is nothing but equals to, just a minute, yeah. Yes, so left hand side and right hand side, so it will turn out to be plus minus root 3. Okay, so x is nothing but plus minus root 3. What are the two different root? It is positive of root 3 and negative of root 3. Now, the method number 2 is the same answer you are going to get, but a different approach using your identity. So you can write this up, x square, 3 can be written as root 3 to the whole square is equals to 0. Okay, now just have a look. A square minus b square is nothing but equals to a plus b and a minus b. If you are comfortable with the identities learnt in your 8th and 9th standard. So what you can write, this can be written as a minus root 3 and a plus root 3. Okay, this is nothing but equals to 0. Thereby you got the two factors. Equate both equals to 0. You are going to get x minus root 3 equals to 0. X plus root 3 equals to 0. Thereby x is nothing but a root 3 and the second root will be x is nothing but a negative root 3. Same answer but a different approach. Whatever you like it, you can follow the same. Now, thereby, the zeros of this, alpha, let be the first zero, be root 3, and beta, be the second zero, is your negative of root 3. Okay, now the second part is the verification. Write verification at the top first. Now, what are the two verification? First, I have to verify, I've written the wrong spelling. So, verification. Yes, first is nothing but your sum of root alpha plus beta is negative b over a, and the second one is your alpha beta is nothing but equals to c over a. Start with the first part, left hand side is your alpha plus beta. Alpha plus beta is your root 3 minus root 3, which is 0. Start with your right hand side, which is minus b over a. Again, here is a trick part. The a is given. If you just expand this, I'll write it as x square plus 0x and minus of 3 is equals to 0. Thereby, in this particular case, if you carefully notice, a is my 1, this is my 1. B, I'll use a different color. This is my a. B is my 0. Don't write B as your 3. B is your 0 in a decreasing order of your power. C is your constant term, this. So minus b over a is nothing but equals to minus of 0 over 1, which is nothing but 0. Thereby, left hand side is equals to right hand side. Start with your second term, that is your left hand side is equals to alpha beta, which is nothing but root 3 times your negative root 3, which is nothing but equals to negative of 3. Your c over a being the right hand side, c over a is what? What is c? C is nothing but negative 3 over 1 negative of 3, and hence left hand side is right hand side equal, both are equals, hence you can say hence verify. This is how you have to explain. I hope it's clear. Any doubts so far? Perfect. Now, just a quick concept once again. If we are just going through, if there are two roots, what if there is a cubic polynomial being given? Also, this is not a part of your syllabus, it's being deducted. But for example, for a greater learning, let's see, I have a cubic polynomial. If I have a cubic polynomial, so the general form will be written as ax cube plus bx square plus cx plus d. This is nothing but a polynomial px. So if I say the zeros of this particular polynomial is nothing but equals to, let's say, I'll name it as alpha, beta and gamma. This is called alpha, beta, this is called gamma. So these are the zeros or roots of this cubic polynomial. Again, the same approach. Ax cube, I'll take ax cube plus bx square plus cx plus d is equals to 0. If the alpha, beta, gamma are the zeros, so I can write this into the factor form, taking a, the leading coefficient out, whatever the coefficient is. Then I'll have x minus alpha, x minus beta, x minus gamma. Why so? Because if alpha, beta, gamma are the zeros, if any point are zeros, then they can be written into their factor form like this, isn't it? Thereby, whenever you factorize your any polynomial px, you write it as x minus something and y minus x minus something. This is the factored form. Anyways, multiplying the right hand side, I'm gonna get what? First, multiply this two term, you're going to get x square minus alpha x minus beta x plus alpha beta. Multiply this with your x minus gamma, you are going to get what? A x cube minus gamma x square. I'm multiplying this by both this, then multiplying this, that means minus of alpha plus beta. I'm taking this as minus of alpha plus beta, and x will turn out to be x square, and minus of alpha plus beta times minus gamma, so it is turning out to be this plus gamma. Then plus alpha beta x minus alpha beta gamma. You can just multiply these up, you're going to get the same thing out. So what I'm going to get? I'm going to get x square, x cube Take the x square coefficient common. You are going to get minus out alpha plus beta plus gamma x square, plus take the x term out. This is your x, no? X terms out. What you are going to get? No, this is your gamma times your x. Yes, this will be gamma times your x. So what you are going to get? You are going to get alpha gamma plus beta gamma plus alpha beta, and then you are going to get your x minus of your alpha beta gamma. Now compare with your left hand side. I'm taking a out as well. I'm gonna get x cube plus b over a x square plus c over a x plus d over a. I hope this is clear so far. Just expanding, taking alpha beta gamma are the roots. Now compare the same way that we did before. So if you compare, see the coefficient of x square, if I compare, I'm gonna get b over a is nothing but your negative of alpha plus beta plus gamma. Again, in a cubic polynomial, this is your sum. So the sum of root is nothing but equals to minus b over a. So we can confirm from here that sum of root is always your minus b over a. Point to be taken is b is always the coefficient of your the x square and a is the coefficient of your x cube. That means 1 degree less than your highest degree. Compare it accordingly. Coming to the next point, compare the coefficient of your x. Here we notice that your c over a is nothing but your alpha plus alpha beta, beta gamma and gamma alpha. I've just arranged alpha beta, beta gamma, gamma alpha. So this is nothing but called as sum of product taken one at time. Sum of product taken one at time. Or taken two at time. Because we are taking two at time, alpha beta first, taking the product, summing it with beta gamma, summing it with gamma alpha. So this is nothing but called as C over A. Lastly, if you come up with the last product, so what is the product being written? This is your product. Comparing it with this, it's nothing but T over A is nothing but minus of alpha beta gamma. So you will notice that product now turns out to be minus D over A. Earlier it was positive C over A. In case of your quadratic ax square plus bx plus c, you have your sum as your minus b over a as it is, but your product being your c over a. But here it turns out to be minus d over a. So how you can generalize for your n degree? For n degree, the sum will be same as, I'll write it as an minus 1, negative an minus 1 over an, where an is the coefficient of a polynomial with degree n minus 1, and an is actually a polynomial, the coefficient of the degree n. And product can be positive, negative, positive for the even degree, negative for the odd degree. So I'll write as minus 1 whole raised to n with a naught over an, where a naught is nothing but a constant term. An is again the coefficient of the leading coefficient or the coefficient of the highest degree, with negative 1 outside. If 1 is even, it's gonna be positive. If 1 is odd, it's gonna be negative. Just a generalized term. I hope this concept is clear. Any doubts so far? If this being clear, we can come up with the question: find the quadratic polynomial, the sum and product of whose rows are given. So again, a simple thing. Now I hope you will be able to solve, because you know how to solve and find the quadratic polynomial. So take a minute, pause the video and solve it up. Meanwhile, I'll start. What is a quadratic? How to find a quadratic polynomial? So I know the quadratic polynomial is x square minus, do remember there is a minus. You have the reason as well, comparing it with the sum. So minus sum of x plus product. Now, what is the sum over here? Sum is nothing but equals to minus 3, write it minus 3 plus 2 being the sum of x, plus product is minus 3 times 2. So it turns out to be x square. What is minus 3 plus 2? Minus 1, but you already have a minus 1. It turns out to be x. This turns out to be minus 6. So your polynomial, the quadratic polynomial, is nothing but equals to this. Simple. I hope it's clear. Awesome. Moving on to the next question. This is actually being excluded from the course. Thereby there is an star asterisk over here. So verify 3 minus 1 and minus 1 by 3. But since I've told you the concept, you will be able to solve it. Verify 3 minus 1 by 3 are zeros of the cubic polynomial this, and verify the relationship between the zeros and the coefficient. First thing first, if you have to verify the zeros of the polynomial, if they are asking you to get the zeros, you have to factorize. If they are just asking you to verify the zero, plug in. Plug in first 3. What you are going to get? 3 times your 3 cube minus 5 times your 3 square minus 11 times your 3, not x. I'm placing in place of x 3 and minus 3. So this is 3 times 4 is your 81. 3 times 3 is your 20. 3 times 2 is your 9. 9 times 5 is your 45. Minus of your 33. Minus of your 1. Minus of your 3. You will note that 81 minus, this is 78. 79, 80, 81. This is 81 minus 81, 0. Therefore, 3 is the 0. Similarly, you have to verify for p being minus 1. Place minus 1 and check out whether it is turning out to be 0. Obviously, if they are asking you to verify, so it will definitely be a 0. This is the homework from my side to you all. And then check out for negative 1 over 3, whether it is turning out to be 0 for you all or not. So this is the way that you can say hence verified. These are all the zeros. Okay. Now they're asking you the verification of the relationship as well. So since we have already covered previously right over here, these are all the relationship between the cubic polynomial. I'll repeat once again. What is that? Sum. Sum is nothing but equals to alpha plus beta plus gamma, which is nothing but 3 plus minus 1 plus minus 1 over 3. Which is nothing but equals to 2 minus 1 over 3. I'm taking the LCM, 6 minus 1, which is 5 over 3. Take the left hand side. This is nothing but equals to, my left hand side is minus b over a. Minus b over a, from here it's nothing but equals to minus, and b is already negative, so it will be negative 5 over 3. So this will turn out to be 5 over 3. Okay, coming up to the product. Taken 2 at a time, that means it is nothing but equals to the left hand side being your alpha beta plus beta gamma plus gamma alpha, and compare it. What is alpha beta? It's negative of 3. What is this? This is nothing but equals to positive of 1 by 3. What is this both? This is nothing but negative of 1. Again the same thing, you are going to get negative 4 plus 1 over 3, which is nothing but negative 12 plus 1, that is negative 11 over 3. Come up with the right hand side. Right hand side being, what is this compared with? It is nothing but c over a. I'll tell you the shortest trick to remember this as well. This is always, if this is written in a decreasing order, this will be always negative. Then take a vice versa rule. If this is negative, then positive and negative. If the other term will be positive, negative. So this always term in negative, positive, and so on. Easiest way to remember. Anyway, we'll come up with what is c over a. C over a will be nothing but equals to negative 11 over 3. And that is what we are going to get. Hence, the RHS is satisfied. Lastly, we are going to get the product of root. The left hand side is your alpha, beta, gamma. What is alpha, beta, gamma? 3 into minus 1 into minus 1 by 3, which is nothing but equals to 1. The right hand side, because it will be negative, so right hand side will be your negative d over a. Thereby, negative is already out. D is also negative. Don't mess up with the sign. Negative 3 over 3, which is nothing but your 1. Hence, equal. So, all these are equal. Thereby, you are going to say, hence, it is verified. I hope it's clear. Any doubt, you can please ping me on your WhatsApp, not on the WhatsApp, obviously, on your YouTube. Comment down below. I'll definitely gonna answer. All right. Now this exercise will be a homework for you all. I'll explain one question and the rest will be completed by you all. If you still have any doubt, I'll take the next session to explain all the questions. First thing first, find the zeros of the quadratic polynomial. Now I think by reading the question itself, you will be able to figure out what we have to do. Find the zeros of the polynomial, quadratic polynomial, and verify the relationship between the zeros and coefficient. So, first thing first, start with the first. If you have to find the zeros, what is the first thing that you have to do? Find the factors. Take it equals to 0. Find the factors. What is the step to find the factors? Take the coefficient of the first term, which is 1, and the last term, the constant term, which is 8. 1 time negative 8, which is nothing but your negative 8. Break down into the two terms so that you can get a negative 2. So I can break it into 4 times 2. 4 times 2 is your 8. But I want negative of 2. How it's possible? 4 times 2 is your 8. 4 plus 2 will not be at negative 2. But if I take negative 4 and positive of 2, then I'm gonna get a negative of 2. So I'll break the middle term. Middle term will be nothing but negative of 4x, positive of 2x. See, negative 4, positive 2, negative 2x. And negative of 8 equals to 0. Take x common from the first term, x minus 4. Take 2 common from the second term, x minus 4. My factors are all perfect, thereby I'm getting both terms same. X plus x minus 4 can be taken out. I'm gonna get x plus 2 is equals to 0. X plus 4, x plus 2 will be taken to be 0. Each factor will be equals to 0 and x minus 4 will be equals to 0. So I'm gonna get x is negative 2 and x is 4. So what are the zeros? Zeros are nothing but alpha being a 4. You can take alpha as negative 2 as well. Beta being your negative 2. Verify the relationship. Verification is nothing but alpha plus beta is nothing but your minus b over a. Plug in, check it whether you are getting the same part or not. Just taking over here only minus 2, which is nothing but equals to 2, minus b over a from here, minus b over here, which is nothing but negative of negative 2 over 1, which is your 2. Yes, they are equal. Taking the product, alpha beta is equals to c over a. Alpha beta, where is my alpha beta? Where is my alpha beta? Yeah, here it is. So this is nothing but giving you 4 times negative 2, negative 8, c over a, which is nothing but negative 8 over 1, negative 8. So hence both are equal. Hence you can solve this up. Do remember to arrange into the proper term. First arrange it as 6x square minus 7x minus 3 and then solve it out. Don't get confused with this. If you don't have the constant term, you don't need to factorize this up. This can easily be factorized with taking 4 and u common. If you take 4 u common, then you will get from here 4 and u are already taken out. So you are just left with u. Over here 4 is taken out, so you are left with 2 because 4 times 2 is your 8 and u is already taken out is equals to 0. So the roots are nothing but u being 0 and u plus 2 being 0 because 4 will eventually turns out to be in the denominator of 0 being a 0 itself. Okay, this we have already discussed the two method to solve. Either you can bring t square is equals to 15, t is nothing but equals to plus minus root 15. Don't forget your plus minus, or you can use an identity that is t square minus root 15 to the whole square, which is a plus b and a minus b. Anyway, and this is all your factorization. This and this are your factorization, even we are third. And the verification. Last question of the day is yours. Find a quadratic polynomial each with the given numbers as the sum and product of its zeros. That means again you must be thinking of, ma'am, it's really simple now. How to find the quadratic quadratic polynomial? Speak up before me. Px is your x square minus sum of root. Don't forget your x, your friend, plus your product of root. Now sum is already given. If I start with the first part, your sum is nothing but roots are already given. Sum will be 1 by 4 plus your another root is negative, so don't mess up with your sign, plus product of root is 1 by 4 and you have to multiply it by negative 1. Okay, so you are going to get px is nothing but equals to x square minus, if you take this out, I'll get 1 by 4, this is 4, minus 1 of x, plus this will be nothing but negative 1 by 4. So if you take the LCM properly, you are going to get a correct answer, which is nothing but 1 minus 4, which is nothing but your negative 3 over 4 of x plus negative 1 by 4. So your polynomial is nothing but x square plus 3 over 4 of x minus 1 over 4. Some teachers will guide you to take the LCM as well, but you are going to get a good mark, you are going to get the full marks at this step as well. Or you can take the LCM giving us 4x square plus 3x minus 1 over 4. This will turn out to be 0, therefore they will give you that the polynomial is nothing but 4x square plus 3x minus of 1. This is also the answer that can be written at the back of your exercise. I hope then this and this you don't have to confuse yourself with this. Just replace the sum with root 2 and 1 over 3. Don't get confused, okay? For example, I'll explain over here the B part as well, just by changing the color. So your px for, let's say, this particular part, it will be x square minus sum of root will be root 2 plus 1 over 3 x plus product of root will be root 2 into 1 over 3, which is root 2 over 3. You can take the LCM x square, but keeping in mind irrational will not disturb me anymore, or I can't simplify it, so I'll have to keep it as it is, giving my answer like this itself. This is my final polynomial. Let's take px as well. Okay, don't get confused with your root as well. This is the most famous question asked many a times in your boards, repetitive question. So you can have a practice of this one as well. But the concept is crystal clear. I hope now you are going to attempt any sort of question. Thanks for watching. It's really been motivated. If you just like on, subscribe and comment down below. I'll be happy to share a lot of videos of mathematics with you all. That's all from my side. Bye bye. Have a nice day. We'll come back once again with the chapter number 3. Bye bye.